Hey there, science enthusiasts. Bill Nye here. Ever thought your brain was just there, like a complicated, squishy hat rack? Well, think again. Our brains are more like a super smart, self-repairing computer. They have hidden talents, folks. One of those talents is trying to fix itself. It's like finding out your old VCR can suddenly stream movies. Mind blown. This intricate network is what makes you, well, you. So what exactly is this multiple sclerosis, or MS? Well, remember those insulated electrical highways in your brain, the neurons? The insulation is a fatty stuff called myelin. Myelin is super important. It's like the plastic coating on an electrical wire. It helps the electrical signals, our brain's messages, travel quickly and efficiently. Without it, signals can slow down, get jumbled, or even stop altogether. Think of it like trying to send a text message with only one bar of signal. Sometimes it goes through, sometimes it doesn't, sometimes it arrives saying aardvark when you meant apple pie. This insulation is key for clear communication within our nervous system. In MS, the body's immune system, which is supposed to be its valiant protector, gets a bit confused. It's like an over-enthusiastic security guard who starts tackling the good guys instead of the burglars. This mixed-up immune system mistakenly attacks the myelin. It thinks myelin is a dangerous invader, so it starts stripping away this crucial insulation from the nerve fibers in the brain and spinal cord. This damage is what causes the wide range of symptoms MS patients experience. It's a real case of friendly fire, but with serious consequences for our internal communication network, affecting everything from movement to sensation. When myelin gets damaged, it leaves behind scars or sclerosis. That's where the sclerosis part of multiple sclerosis comes from. So our brain's wires are frayed. The myelin insulation is damaged. Is it all doom and gloom? Not necessarily, because our brains have a secret weapon: remyelination. Say it with me, remyelination. It sounds complicated, but it's actually a pretty neat process. It's the brain's natural way of trying to repair that damaged myelin. Think of it like your body's own team of tiny, highly specialized electricians. When they see a frayed wire, they try to patch it up with new insulation. It's a built-in repair mechanism. Pretty cool, huh? This ability is a fundamental aspect of our brain's resilience. How does this remyelination magic happen? Well, deep within our brains there are special cells called oligodendrocyte precursor cells, or OPCs for short. That's a mouthful, I know. Let's just call them Ollie's pre-repair crew. These OPCs are like trainee electricians waiting for their call to duty. Section 4, the remyelination race of mice and hopefully men. Alright, science fans, let's talk about the exciting stuff, the research. Scientists around the globe are in a race, a remyelination race. They're looking for ways to kickstart or enhance the brain's natural ability to repair myelin. Think of your brain's wiring like a tangled mess of old Christmas lights. You know the ones. Some bulbs are out, some are flickering. Remyelination research is like trying to find a way to magically fix all those faulty bulbs and untangle the whole mess, making everything bright and shiny again. It's a big task, but the potential payoff is huge for so many individuals affected by demyelinating diseases. Researchers are exploring all sorts of clever ideas. Some are looking for drugs that can wake up those sleepy Ollie's pre-repair crew cells, the OPCs, and get them to work faster and harder. Imagine giving them a super caffeinated energy drink, but, you know, scientifically formulated. Other scientists are investigating molecules that can protect the existing myelin from further damage, like putting a tiny force field around each insulated wire. They're also studying why remyelination sometimes fails, trying to understand the roadblocks so they can clear them away. Section 5, Clinical Trials, Be a Science Superhero. Now, we've talked about amazing discoveries in mice, but here's a crucial point. What works in a mouse, or even a monkey, doesn't always work the same way in humans. Our bodies are incredibly complex. Think of it like this. A recipe for a delicious mouse-sized cupcake might need some serious adjustments before it becomes a human-sized wedding cake. There are different ingredients, different cooking times, and a much bigger oven. Translating research from animals to people is a giant leap, and it requires a lot of careful steps, meticulous planning, and rigorous safety evaluations to ensure efficacy and well-being. This is where clinical trials come in. Clinical trials are super important. They are the bridge between a promising idea in the lab and a new treatment for patients. These are carefully designed research studies involving human volunteers. Their goal is to see if a new drug, therapy, or medical device is safe and effective. It's not like those mad scientist movies where they zap you with mysterious rays. Oh no. Clinical trials are highly regulated, with many safeguards in place to protect the participants. Safety first, always. Ethical considerations are paramount in every phase of these trials. Participating in a clinical trial can be a heroic act. Section 6, The Future's Bright and Myelinated. Don't forget to like and subscribe. So, can your brain repair itself? The answer is a resounding yes, it can try. And with the incredible research happening in remyelination for MS, we're learning how to help it do an even better job. The future is looking brighter. It's not just wishful thinking, it's based on solid science and dedicated researchers working tirelessly. Imagine a future where we can effectively repair myelin damage, potentially stopping MS progression in its tracks, or even reversing some of its effects. That's the goal. And science is getting us closer every single day, offering tangible hope for significant improvements. It's like we're finally giving the brain's tiny electricians the advanced toolkit they've always needed. Better blueprints, stronger materials, and a whole lot of scientific cheering from the sidelines. The journey from a frayed wire to a fully insulated, perfectly functioning nerve connection is complex but no longer impossible. This research offers so much hope. Hope for improved quality of life, hope for new treatments, and hope for a future where MS has less power over people's lives. It's a testament to human ingenuity and our relentless pursuit of knowledge to overcome challenging diseases. The path to conquering MS is paved with research, and research needs support.